Hello everyone, in this video we are going to solve a CSES problem called two sets. So you are given an integer n and the task is to divide the numbers 1, 2 up to n into two sets of equal sum. And the output says if we are able to do so, we print yes, and we print the one example of how to create the sets. And otherwise, we print a no. To solve this problem, we can start by checking the sum of the two sets. So if we write out all the sum, it should be equal to 1 plus 2 plus 3 up to n, right? And that equals to n times n plus 1 divided by 2. And this sum, if it is a number, then we knew it. There should be no way to divide the set into two equal sums, right? So if the first case is if s is an odd number, then the answer should be no. So otherwise, if s is even number, what can we say about value n, right? So there could be two cases about n, where n could be an even number, or n could be an odd number. Okay, so in the case where n is an even number, what can we say about the sum? So we know that n is even and s is even. So because n is even, we know that n plus 1 is odd. This is even, this is odd, but the product themselves should also be even. So that means n divided by 2 should also be even number. N is actually divisible by 4. Right? So n is divisible. On the other hand, if n is an odd number, in this case, we know that n plus 1 is an even number. Right? So in this case, it means that n plus 1 divided by 2 is still an even number. So what can we say about it is that n is in the form of 4k plus 3, because n plus 1 is a multiple of 4, so n should be like in the form of 4k plus 3. Okay, so these are the two cases where we want to solve, and for each case we can actually find some way to separate the set, divide the set into two parts of the equal sum. So in the first case, what we can see is that let's just put all the numbers n minus 1, n minus 2, n minus 3, right? So we know that by adding these, the first term and the last term, by adding them together, they should be equal to 2 plus n minus 1, right? So they should be the same. So you can grab them, like split these numbers into groups of 4 numbers, right? Because n is divisible by 4. This is very important. And we can put the first pair into the left-hand side and the second pair into the right-hand side, and so on and so on. So after we're doing this, we are able to split all the numbers into equal sum, and each group itself already have the same sum. So what can we say about the second case? In the second case, when n is odd, there's a trick. We still want to form groups of 4, right? But there could be the last group, or there should be one group that cannot have 4 numbers. So one trick here is that we can observe that the first two numbers, 1 plus 2 equals to 3, right? So that shaves off the 3 numbers. And then for the remaining numbers, starting from 4, 5, 6, 7, up to n-3, n-2, n-1, and n, we still do the same trick as the previous idea. Okay, so that gives us the construction of a solution, right? We just come up with some solution and show that, the answer is always yes. Okay, so this is the idea of how to solve this problem, and let's try to code it up. So to code this up, we first create a new file, and then we read the number. And whenever n is, we just compute the sum, right? As n times n plus 1 divided by 2. If s is an odd number, then we know that it must be a no case, right? Otherwise, there is some way to do it. So it depends on whether or not n is an odd number or not. So if n is an even number, then we can follow the first case where we group the numbers into groups of 4, right? So basically what we can see is that we just put the first number into the left-hand side, the second number into the right-hand side, and so on, right? So it creates 2 sets, left set and the right set. So what we can say is we just run a for loop starting from, let's see, I equals to 1 up to the half of n, right? So something like this. Okay, and if I is an odd number, it must be like 1, 3, and 5, and 7, and so on. So we put it to the left, and we also put the other side of the pair. Otherwise, we put it into the right. So they will have the same sum. Okay, so this is basically the case of n is a even number. Let's put these 2 things into the front. Okay, so otherwise, if n is an odd number, we can still do the same thing, but now the left-hand side can have start with the 2 numbers, and the right can still have the 3. So they start with the same sum, and then for each I here, starting from 4 up to like n plus 2, n plus 3 divided by 2 or something. Okay. Right. Wait, we need to include that also, right? So it's odd number, and we want to do this if I is an even number, put it to the left. And if I is an odd number, we put it to the right hand side. Okay, so that's the, well, I think we probably need one there. Let's try this. And at the end, we want to output the both sets. So to output the both sets, we first print the size of the left set, and then we print out the set of the left side. So that should be, we just make all the number into strings, right? So something like this, and we just join them with space. And then we do the same thing for the right. Okay, and that should be all of it. And I think we also need to print yes in the beginning. Okay, let's try this. If we input 7, and it gives us 1, 2, 4, and a 4. Why? Oh, sorry. It now add up to 7, right? So it should be m plus 4 minus I. Okay. Let's try this again. Now we have the right number. Okay. If n is 6, then we should output now. Okay, that should be the case. And let's try to submit it. Aha, let's get accepted.